Quickly, a little bit about me. As I said, I'm a SREA generalist at Stack Exchange, so I touch just about everything on the stack, from the network stack up to the Windows, Linux, anything that needs to be touched, contact information. So a brief overview of what we're going to be talking about. This is some of the statistics from the Stack Exchange sites. We do about 560 million page views a month, which equates to about 34 terabytes of transferred data a month. Our requests per second is in the 1700 requests per second at peak, which is generally when people are getting in East Coast time. Starts around 9 a.m. East Coast, goes to about 1 p.m. East Coast time. We'll see about 2,200 requests per second across our web farm. Our stack is the Windows IIS, MS SQL, and C# stack with some HA proxy, Elasticsearch, and Redis thrown in for good measure. So a little bit about what's going to frame this talk. At Stack Exchange, our first priority is performance. Make it go fast. Get the page to you as fast as we possibly can. Nobody likes a slow site, and there are some actual problems if your site is slow. Google starts to ding you a little bit on your site rankings if your site is slow. If you want to read up about how that ranking is done, there's a great article on Moz.com about exactly the way Google uses speed as kind of a signal for site quality now. So just to frame kind of where we're at, we're going to concentrate a lot on performance, and as we go through the performance, that's how we kind of design our infrastructure and give you a little bit of background on why we design things the way we do. Just so for performance, we have a couple of tools we've built in-house that give us some visibility into our performance. The tooling out there, we started working on this stuff 3 years ago or so. We had a big company push to allow for making the sites faster. We're seeing things were kind of slow. So the first project that came out of this was Mini Profiler, and it's actually an in-page little pop-up that tells you exactly where your site's being slow and how fast it's taking to load the page. Then came OpsServer, and OpsServer is kind of our single pane of glass across all of these different dashboards we've had. So, your monitoring system has a dashboard, and SQL Server has another dashboard, and Redis has kind of metrics, but they're hidden behind API routes, and Elasticsearch has the same thing. So we wanted all of that stuff into one place to give us kind of an overview of the health of our system and how it was performing. And the final piece that's been most recent and part of our SSL and transition to Cloudflare is we wanted to see how the page was actually loading for real people. And recently, in the past couple of years, browsers have integrated some timing statistics into the engine that you can grab via JavaScript. And so we started collecting those and bringing those into our logs. If you're curious about exactly what we're looking at, it's just loaded in an iframe on our site. You can go to teststackoverflow.com, and it'll show you exactly what we're storing as far as client timings and a little explanation of what they are. So the first thing is, I said Mini Profiler. One of the key features of this is we've set it up so that it's shown to every dev and every SRE on every page load of every site on our network. So we have, in the upper right-hand corner, we have page load time, and that makes it very visible right in front of us. That way, everybody who's involved in running the sites and coding the sites now has that always-on visibility of how fast is this page loading. This slide is just an expanded view of exactly what we see when we click on the timing. As you can see, you've got how long it took to grab the page, SQL timings, all sorts of really good information. And you can go in and you can share that with other people. You can show there's some trivial stuff that just takes less than a millisecond. And if you really want to see everything that loads the page, you can go through and see that. I would definitely, anybody who's running a web app, this has been ported to just about every language out there. C#, Python, Ruby, PHP, Java. I would definitely suggest looking into this and getting this in front of your website developers, because it's a great way to see how your site is actually performing. Our next step was OpsServer, and there's a couple of things that were going wrong when I took this screenshot. One of them was mostly because I broke our logging Elasticsearch instance and then decided to work on my presentation instead of fixing it. So what this does is, this is our dashboard view of Observer, and what we have here is just a view that bubbles up problems. So on the top right, we have tabs that dive into each of our systems, and it's a fully plug-in. You can enable the tabs you need. If you don't use MS SQL, don't enable that tab. If you use HA proxy, you can turn that tab on. It's fully customizable, and we're working to get it actually a little bit more customizable over the next month or so with a plug-in infrastructure, so you can write to it whatever you need, and not just what we've needed and have published. But you can see it's telling you something's wrong, and you can click and dig and go through that. Just a little bit of a deep dive into some of the other views. This is HA proxy. It's showing us we've got some web servers down, and it actually has some control. We can start and stop backends and pull servers in and out. Just a little bit more detail tells us exactly. Basically, if you've ever seen the HA proxy stats page, this is a prettier view. And then Redis, we've got tons of information about slaving and standalone instances and where they're at. We built the Observer MS SQL mostly because this is actually what started Observer, because with the first generation of SQL always-on availability groups, the dashboard couldn't be trusted. If you went to the dashboard from a slave or a non-communicating server, it didn't update the fact that it was not communicating, and so the cluster could be broken, and the server you're looking at would still think it's healthy. So we actually, this is why we started writing Observer, so we could actually have the view in, and then it's grown into this awesome tool. And as you can see, it tells us the status of all our slaves, how much memory, data transfer, how the database replication is going. And the final tool, this is just kind of, this is the test.overflow.com screenshot of that. This is what you see if you go to that URL. And this literally just inserts into our log system, so we can use it as part of our performance analysis and figure out how long it's taking to load the page from basically anywhere in the world. We generally have this on for about 1% of the clients at a time, the users at a time. Just take a little sample and see how we're doing. So these are the tools we've been using. And now, we love being fast, but if you're not up at all, you're not fast. You're the slowest you could possibly be if you're not up at all. So now we're going to kind of get into how we actually design these things, because we have the performance and we have the uptime. We want to make sure we're up and we want to make sure we're fast. So we design a highly redundant network where we have redundancy at the data center level. We have a data center in New York. We have a data center across the country in Oregon. We have 4 ISPs in our primary data center. In our secondary data center, we have the ISP, the colo providers are giving us a blend of multiple paths to their multiple ISP blend. Our edges, there's at least 2 edge routers, 2 firewalls, 2 core switches. Make sure we have that redundancy, which not only keeps us up, but allows us to do maintenance a little less painfully, so we don't have to break everything. Like if we did a core switch upgrade a couple weekends ago, and we failed over to Oregon just to be sure, but we were able to upgrade our cores one at a time, and we only lost a couple of things where the human factor came in and we hadn't fully wired the servers yet. So what does this actually look like? So this is a look at our network design. We've got, it's horribly clipped up there, I'm sorry, but we have 2 tiers of network connectivity, each with 2 ISPs in it. The first tier of network connectivity is kind of what we call the low-end tier, where it's hosting stuff. If it goes down, the sites will keep functioning. So our WebSockets are hosted out of there. Some of the secondary services, blogs, and the kind of stuff that if it goes down, we don't care. The site reduces in functionality. You won't get live updates, for example, if the WebSockets do go down. But you can still get your questions answered, and that's the most important thing to us. All of it's just the rest of it's just gravy to us, and it makes it look nice. But if you can't get the answer to your question, we're failing. So each of those come in down into redundant routers, which feed into a DMZ. So let me back up for a second. The secondary one is on tier 1 ISPs. The primary one's on tier 2 and 3 ISPs. The primary one has, as you can see, it's a much more highly available solution, doing full BGP tables and HSRP into a dedicated VLAN so we can flip back and forth, and everything's very, very highly redundant. The other side, it's just kind of an active passive failover. We can move back and forth. We'll probably have some time where you can't get to those services for a little bit. But you know, when you're designing these things, it does come down to money at some point. And I can't go to the CFO and say, hey, for the stuff we don't care about, I want to spend $500,000 making it highly redundant. It just doesn't make any sense whatsoever, right? Once we come down into our network, we hit our load balancers. Our load balancers consists of an active passive HA proxy pair. So the really fun part about that is every request that comes into our site, website, WebSockets, all the ancillary services actually flows through one active physical machine. And what that actually means is we have one HA proxy server servicing about 4 billion requests a month, just one active machine doing it. And to do that, it actually doesn't take a whole lot. It takes a lot of tuning. We've had to do a lot of work on the network stack, get rid of stuff like connection tracking and some of that other like nice to have things to be able to process these things very fast. One of the things we did just about a week ago was our IP tables rules were causing high CPU. We have some rules in there for people that really kind of try and DDoS us or try and scrape our websites. And we have about 600 lines of IP table rules that what happened was it was starting to spike the CPU and use almost all of a single core as we're trying to sequentially run through and look at these requests. We moved to a set command, and I didn't do it, so I can't talk very smartly about it, but it dropped our CPU way down. To service these, so those requests, it's about 3,000 requests a second at peak. And to run that, it takes about 10% of our CPU of one machine. At peak, it's closer to 20% when we're really getting a lot of requests. Because of the way stuff like WebSockets work, which are really interesting, they're very, very, very long-lived TCP connections that just kind of, they'll stay up for days if we let them. At any given time on our active load balancer, we'll see 600 to 700 concurrent, I think that's 600,000 to 700,000 concurrent connections, yes. And that's in the multiple states, established, time, weight, et cetera, all those different states that are still using up that TCP slot. So how do we get this? Because HA proxy is a single-threaded process, right? There's only so much one CPU core can do. It's not multi-threaded. Not quite true anymore with their SSL. There is some multi-threading in there now with SSL, but the main HTTP load balancer is single-threaded. So what we actually did was we broke everything apart. We said, instead of having one front end and one back end and one process that handles basically everything, we're going to break that out into different tiers. And that's going to allow us to attach these different processes. So right now, I believe we have 5 or 6 different tiers, and each one of those is a separate HA proxy process, which allows us to put that on a different core. And so we can now kind of sort of have multi-threading, but it's multi-threading in the fact that we're sending you somewhere else, not the program's doing multi-threading. And that kind of helps us keep, so we've got these giant boxes with 18 cores in them, and when we first got them, we were only ever using one core, which very weird to look at. You've got this nice new box, but now we have these processes broken out. And with SSL, there is starting to be more multi-threading just because you have to do that to actually process SSL. I know people say SSL's cheap these days. When you start getting into large loads and you're doing it on one machine, SSL's not as cheap as you would think, and it's a little bit more complex. You know, most people cite the Google study. It's like, oh, it only uses 1% of CPU on our web front ends, right? But they've also got 500,000 web front ends. So not everybody can do that. So this is our request flow. This is how a request actually comes in to our load balancers. It comes in and it says, okay, where am I coming in? We've got it divided up by DS name, so like Stack Overflow is going to a different one than our career site, than our chat services, than our blogs. It comes in and says, okay, are you an SSL request? Great. I'm going to terminate you and loop you back around, and you come right back into the standard HTTP front end that everybody uses. If you're just a regular HTTP request, great, you're going to go through, you're going to hit our ACLs, you're going to hit our rules and all that fun stuff. And then you're going to be sent along to a web back, an IIS server to actually do the application processing. So SSL, everybody wants SSL on everywhere. Our users were very loud about this, and we have worked slowly. It's not quite, you know, as I said, it's not as easy as you would think. It's getting easier every day as people are pushing to get SSL into all these products. We used to use Nginx for an SSL termination and then loop it back. HA proxy at 1.5 dev 15, I think it was, introduced SSL. 1.5 is now production and released, so you can go and use it. But we've been on the beta software for, I don't know, 5 years, way too long. And having SSL in one process kind of makes life simpler so that we only have one place that we need to go configure all of our load balancing needs. We don't have to go, well, this site needs SSL, and I've got to go configure it over on Nginx and make sure it's talking properly and setting all the right cookies. HA proxy just sets all that stuff and does the work for us. I wrote a very extensive blog post about how this whole setup works. It's there, and I will publish my slides after this presentation so you can get to all the links and see what's going on. The one thing I do like to kind of point out is the way we're doing this. So if you think about how a TCP connection is established, it's an IP address and a port going to an IP address and a port. So the problem we actually ran into was running out of source ports on our load balancers. When we're trying to load balance for 500,000 connections over it, going through SSL and working its way. So what we actually had to do was go in and use the loopback addresses. And what we actually, it looks kind of funny in our config. So what happens is when you come into SSL, it's then load balanced across 127.0.0.1, 127.0.0.2, 127.0.0.3. There's 10 or 15 of them, because when we just do the 127.0.0.1 loopback address, we ran out of source ports and all of our connections start failing when they come in over SSL. That made for some interesting troubleshooting. And it's one of those things you don't really think about until you've got a lot of connections coming in. And it's, you know, you also forget that there's more than one loopback address some days. Even when we put SSL back on, it didn't add that much CPU once we tuned it. The other thing with SSL is you have to tune it. All the default configs will chew your CPU and chew your memory. You have to limit what you can, limit the cipher suites, limit, use all the OSCP stapling, all the new features that you possibly can to make sure that you're not redoing all the computation. We're not quite there on SSL everywhere, but hopefully in the next year or 5, we'll have finished getting SSL up and running on all the sites and people can use them all the time. The next piece of our stack is our web servers. So all of those web requests, they come into 9 production IIS web servers. That's it. If you're hitting a Stack Exchange site, you're hitting one of 9 production web servers, unless you're hitting the meta site or you're a developer hitting our dev site. So those run on a load balance pair, which weren't actually load balanced till about 2 years ago when we ran into a load balancing bug and nobody caught it because our dev site wasn't load balanced. So these are actually fairly old machines. They're Dell R610s, which is the 11th gen. They're about 4 years old, 5 years old at this point. They run between 15 and 30% CPU, handling 185 requests a second and about 250 at peak. This slide's actually wrong. We just upgraded to 48 gigs of memory on them. That was a fun day. I don't know if any of you have dealt with, this was the first generation of hardware that had the memory controller on CPU. And it was very, 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 very picky about memory ranks and lanes and channels, and you have to put your memory in exactly the right way, otherwise it will complain and not see all the memory. So when we upgraded these, when we added 16 gigs of RAM, you'd think for 9 servers you can do that in an hour, so it took us about 4 hours to get it right, just because of how specific those particular processors are with how they want their memory configuration. For our data tier, we use MS SQL Server. We're using the always-on availability groups for in data center and multi-data center redundancy. We have 2 servers in our primary data center and a 3rd one in our secondary data center, and it takes care of replicating everything. Inside of our primary data center, we have a read-write SQL server and a read-only SQL server. The best part about this for us was we were able to offload stuff like our API reads to another server. So we're essentially, with our API, we're essentially letting anybody make a query against our database. So we can control that somewhat, but people will write some really crazy stuff against our API. Moving that off to our read-only, where if somebody pegs the CPU for 5 seconds, we'll be annoyed, but it's not going to take the sites down. So just what are these handling? We handle about 340 million queries per day against these SQL servers. At peak time, there's 340 million queries on Stack Overflow. We've got them separated into 2 separate clusters, one for Stack Overflow and one for everything else. So Stack Overflow is 343 million queries per day, 7,500 queries per second at peak time. Stack Exchange, which is the everything else cluster, handles 216 million queries per day and about 3,200 queries a second at peak. And we do that without really taxing the servers too much. The Stack Overflow database server runs between 10 and 20% CPU. At peak, we'll see it get up to about 30% CPU. Stack Exchange, it runs about 10 to 15% CPU, might spike up to about 30%. And some people ask us, well, why don't you run them hotter or run smaller servers? Well, we do that so that when bad things happen, we can stay up. We don't have a situation where something hits, we've had people attack us finding slow routes, and our CPU will go up. But we'll stay online and we'll still serve those answers to those questions. So that's everything. It might get a little slower, but we're okay with that as long as we're serving them. And we've also run into, we've found some bugs in SQL Server where execution plans don't get cached correctly, and we've all of a sudden are generating a new execution plan for every single query, which we've had happen, and we've caught and worked with Microsoft and gotten it fixed, but we didn't go down during that time, just barely. I think we were at about 95% CPU at peak during when we ran into that bug. But this is all about how we can be it's redundancy, resiliency, and availability. And yes, we want to be as fast as we possibly can, but we would rather be a little bit slower and still serve you your answers. The next bit here is we use a caching tier, which is a Redis cluster. So we have a master and slave Redis instance in our primary data center and a single slave instance in our secondary data center. The the master Redis instance does about 3.6 billion operations per day. Every request has some sort of caching involved, and all of our caching goes through Redis. So you have a lot, and we've run into bugs with Redis, and we kind of push things as hard as we possibly can, and we don't enjoy finding the edges of performance, but we love being able to fix for everybody else those performance issues we have at scale. So the peak on those is about 60,000 requests per second, but we're only using about 3% of our CPU to do that at any given time. So Redis is very, very efficient for us and has worked very well. One of the interesting things we have is a tag engine. This is a bespoke piece of software, and it wouldn't be useful to anybody but us. Basically, what it is a special index of Stack Overflow, Stack Exchange. The problem it's solving is we grew to such a scale that the SQL Server full text indexing couldn't keep up. When all of our tags were queried through full text indexing for till about 2 or 3 years ago, and then it started falling over with just the way it worked. If you're very interested in all the technical debt and problems that was called, there's an excellent blog post by Mark Ravel, who wrote the tag engine. So basically what happened is we wrote a custom piece of software that is basically a big array of our tags, and it lets us figure out what tags to display and what tags to suggest really, really, really fast. Handles about 3,700 requests a second at peak. Just basically every time somebody wants to see a tag or search by tag, you've got that. How it actually works is it's basically a sub-project off the Stack Overflow project, and it takes a full copy of Stack Overflow, sucks in all the data, and stores it in this giant in-memory structure, which has some interesting implications with the garbage collection, because it never goes away. So there's some really insane things that Mark did to solve those garbage collection by basically working around it. And the first sentence in his blog post about that piece of it was, "Don't ever do this." But it allowed us to be very, very fast and serve the pages faster. Once it gets all of that in memory, it does some checks and makes sure everything's good. And it notifies through Redis the web servers that, hey, I'm here, I can take requests now. One of the kind of cool and interesting things he did was he designed it in such a way that they can just do a build and it'll upgrade and nobody notices. It doesn't take the server out. It doesn't cause any alerting to happen. So what happens is it stands up the two instances, the new instance and the old instance side by side in memory. And once the new instance has fully gone through and done all the pre-flight checks, said, okay, I'm good, it then changes the Redis key to say, hey, you got to go over to this instance now. And once there's no more requests pending for the old instance, it spins it down, which is very nice for everybody involved because the developers can write something and push it, and if they break it, it's their problem. But nobody else needs to be involved in the deployment. It's just the continuous integration server goes, builds it, puts it in place, lets it spin up, and nobody cares. I can't even tell you how many times they've redeployed this. Actually, I can, because there was a bug, and it wasn't removing old binaries. And last time I looked, there was about 1,000 old binaries in a temporary folder that filled up our disk space. That bug's been fixed, but it doesn't involve us, and that's kind of a good thing where SRE doesn't need to know about tag engine upgrades. We couldn't fix it if we tried because it's such a custom piece of software. We would have to go and get the developer anyway if something was breaking. So that's very, very interesting. We use Elasticsearch. So anytime you go in the upper right-hand corner, you can, when you don't use Google to get to our site, you can search inside of our site. and we put everything into Elasticsearch, which is basically a very nice wrapper on Lucene. And the index is 203 gigs. It's a three machine cluster. It's not a very big cluster. People honestly use Google more often than our own internal search. But it still does about 42 million searches a day, which is not a small number. So honestly, there's not a whole lot of tuning we've done with this Elasticsearch instance. It's not a very big Elasticsearch instance. If you go out and, there's some companies out there doing multi-petabyte document stores in Elasticsearch. So a lot of the defaults work for us here. One of the more interesting pieces is we're working on getting the Elasticsearch Logstash Kibana infrastructure up to move all of our system alerting logs to. And we built out a 300 terabyte Elasticsearch cluster. And we've had some interesting problems, like we accidentally broke all the data with a network split. And we had to resync good data from bad data. And at that point, we weren't really sure what we were doing. So we just kind of took some knobs and tuned them. And there's a bunch of knobs you can play with for bandwidth and limiting. Elasticsearch tries to play nice on the network by default. Has some very low throttles. We basically took those off and watched I think at the time it's about 11 terabytes of data that needed to be replicated. Watched that peg all of our network gear, and we were pushing about 30 gigs a second through our core switch when we were re-replicating that, which was fun to see. So that's our basic stack. That's how you get stackoverflow.com to come up on your screen, do searches and all that fun stuff. So how do we get that code to the servers? Well, we recently transitioned to Git. We used to be on Mercurial. We've moved to Git using GitLab, which is internally hosted. We were hosted on Kiln, but one of the problems we had with Kiln and one of the problems we've had with GitHub is availability. If we can't get to our code repos, we can't build, which has very interesting implications if we're in an outage and we need to build. We have some projects that need to be built to change what server it's pointing at for its database. We're trying to work out getting that type of stuff moved into Redis so that they just look up the key of where they're supposed to go, but we're not 100% there. So we decided to go with GitLab internally hosted, which once we kind of figured out how to run it in a highly available way, it's now available. And at the absolute worst case scenario, we can go to that server and grab the code, which allows us for that redundancy. So once it goes into Git, we use TeamCity as our continuous integration server. And that just sits there looking, for the most part, it just looks at our internal Git repos and says, oh, there's a new change set, and then I'm going to grab it, I'm going to build it. And depending on the service, so like our core sites, it'll grab it, it'll build it to dev, and then the developers will go and look at it, but it's a manual push to prod. So every time the devs iterate, it'll automatically go to dev, and then once they're like, okay, this is good, they go and click. It's one-click manual push button, but they go click the one button, and it pushes the artifacts from the dev build to the prod build once everybody's happy with it. And this is done through some custom PowerShell scripts. It was just easier to do it through PowerShell since we're deploying to IIS. So we have some custom scripts that go through, and they'll call out to HA proxy, take the server out of rotation, literally just copy the files in place. There's nothing special about how we do our deployment. It's a robocopy into place, reset the IIS server, make sure all the app pools come up, and re-put it back and take it out of maintenance mode in HA proxy. It's a dead simple deployment methodology, and we love it. One of the things we kind of say internally is, I'm going to build this the stupidest way I know how. Which by stupid we mean really the simplest way. We're not going to have things. We don't want to have, okay, well, let's have a build with a messaging bus and some SQL lookups and all this other stuff. No, we literally just need to copy files in place, and that's what we do. It makes life for everybody just easier, where you know, all you have to say is it's doing a file copy. Everybody in this room knows exactly what you're talking about. So doing all of this work gets you 52 millisecond homepage render time and a 33 millisecond questions page render time, which is awesome. We'll get that page out to you fast, and then we'll run into the speed of light. So if you're near New York, you're going to get lightning fast responses. If you're in Australia, it's going to take longer. And we're working on some ways using CDN and other kind of methodologies over the next year or so. We want to start getting stuff out closer, pushing content to the edge, so that we get these kind of awesome, sub 100 millisecond render time, page view times out to everybody in the world. And if you ever are curious about how our performance is going, we recently put up stackexchange.com/performance, which is a real-time display of our performance and what's going on with our servers. It pulls directly from our monitoring systems. You can always see, do we have a server in rotation, how many requests per second we're doing, what are we doing. So if you're ever curious, hit there. And I think I have about 13 minutes for questions. And thank you. I will have office hours 2 to 3:30 over at the LISA lab. Yeah?
What process did you go through to pick your ISPs?
We contacted a broker. Oh, sorry. So if you wanted to know what process we went through to pick our ISPs. So the first thing we did was look at what ISPs were in the data center building we're at, which is a ISP neutral. So we had about 15 ISPs to pick from. And then we basically said, half of them were tier 2, 3, half of them were tier 1. We went through and basically kicked some off the list that we've had bad experiences with in the past. And then we had a broker actually go out and get us quotes and work on that for us. So once we got the quotes, and some of them came back at just such ridiculous rates where we're like, you're out. Once we got that, we worked with actually our colo provider, and they stood up a virtual machine for us to run some tests across the ISPs with. So we ran just basic transfer tests, ping tests, that type of stuff, see what it looked like out of that facility. On the border, so we use HSRP for inside going out, and BGP. We just use BGP for outside coming in. On our primary nodes, we do full tables, and we have our own IP space, and we announce it. On our secondary node, we have to fail over. Although we do see traffic coming in both sides, just because we're announcing out of both. We use some communities to try and set preferences, but that only goes so far.
Is there a reason why you favor a more monolithic architecture?
Simpler. Simpler, easier to manage. It's worked for us. I mean, if we ran it, we want to keep, one of our things is we always want to keep things as simple as possible, because it's easier to troubleshoot, easier to expand, easier to build out. Now, as you grow and you run into problems where you need to grow horizontally, or less, kind of break things out, we'll do that, but we don't want to prematurely do that, because that just makes everybody's life harder having to manage that stuff. Yeah?
Are you doing BGP in the Oregon data center as well?
We are doing, our provider out there is re-announcing BGP for us. We're working on upgrading that site in the next year or so to be more in line with the way we do things in New York. We just recently overhauled basically our whole design in New York, and now that it's kind of baked for a year, we're looking to get that design pushed out to Oregon. Yeah?
Sort of a follow-on question. When you go to fails over, I've seen it where you put the site in read-only, and that's, I'm assuming
Yes, so we have a couple of failover scenarios. Our primary one for like maintenance and short-term failovers is just go into read-only mode, which lets us avoid the pain of having to sync back writes and that type of stuff. We'll go, when we have to actually internally in our data center, when we have to failover, there's about 5 to 30 seconds before all the IP addresses are moved and everything's kind of settled down, so we'll go into read-only mode then. Or sometimes we'll just take the site hard offline for that 30 seconds and bring it back up, depending on what we're doing. But yeah, read-only has a lot to do with syncing across the country and making sure everything stays in sync. Yeah.
How did you get the buy-in for MS SQL versus any other database?
There was no buy-in. The founders started on a WISC stack, and that's what we've used. So if you're, and yes, MS SQL can get expensive really quickly depending on the features you're using. So it's more expensive at this point to port to another database layer than to do the licensing. Yeah. How many people are working here? We have about, this is actually, so we had our yearly company meetup 2 weeks ago, 3 weeks ago, and we were all surprised that we had a room full of engineers, especially those of us that have been here for 4 or 5 years when there's 8 engineers. So right now, I think we have about 35 or 40 engineers, so that's dev and IT SRE, and I think on the sales side, we're close to 150 people. So it's not a small startup anymore. But yeah, the one thing that after the first day of IT engineering meetings, everybody's like, I did not realize there was that many of us. We filled up a room. Because half our people are remote, so you just kind of, you don't get that, you don't visualize that, right? And it was very interesting to get that reaction when we're like, wow. Anything else? Awesome. So once again, I will be having office hours if you want to talk about anything in depth. 40 minutes wasn't really nearly enough time to cover all of this. From 2 to 3:30 over at the LISA lab. And Tom's going to come up and talk me off the stage now.